The National Electrical Code, or NEC, mandates specific working space requirements in front of electrical equipment, including panels. These requirements are designed to ensure the safety of personnel who may need to access or work on the equipment. NEC 110.26. It stipulates that at least 30 inches of working space must be provided in front of electrical equipment. This space should be clear and unobstructed to allow for safe operation and maintenance. The depth of the working space, which is the distance from the front of the equipment to any obstruction, is determined by the voltage to ground and the condition of the space opposite the equipment. For example, for equipment operating at 150 volts or less to ground, and where there are exposed live parts on one side and grounded parts on the other side of the working space, the minimum depth required by NEC 110.26 A1 is 3 feet. It is important to consult the specific requirements in NEC 110.26 are based on the voltage and conditions present. NEC 110.26 E1 addresses the lateral or sideways placement of the working space. It states that the working space may be located on either side of the equipment. This means that the 30 inches of required width does not necessarily need to be centered on the equipment. As long as there is at least 30 inches of clear space available to one side or the other, the installation can be considered code compliant. Consider a situation where a rebar is present near the electrical panel. If the rebar is 6 inches to the left of the vertical footprint of the panel and the panel is 4 inches away from the wall, then the working space to the left of the panel is calculated by subtracting these distances from the required 30 inches. In this case, 30 inches minus 4 inches minus 6 inches equals 20 inches. Since there is at least 20 inches, this would meet the minimum working space requirement in front of the panel, even though the space is not centered. Remember to ensure that the working space is clear of obstructions. This includes tools, materials, and any other items that could impede access to the equipment. Additionally, the rebar should be properly bonded to the electrical system using an approved bonding method. This is typically done with a copper or aluminum conductor connected to the grounding electrode system. To elaborate further on the NEC requirements, let's break down the key aspects of 110.26, which cover spaces about electrical equipment. This section of the code is paramount for ensuring the safety of individuals working on or near electrical systems. The primary goal is to provide adequate space for personnel to safely operate and maintain electrical equipment. 110.26 A, as previously mentioned, focuses on working space. The core requirement is the 30-inch width in front of the electrical equipment, but there's more to it than just that. The code specifies the depth of the working space, which is the distance from the front of the equipment to any opposing surface. The required depth varies based on the voltage to ground and the conditions present on the opposite side of the working space. Condition 1 is where there are exposed live parts on one side of the working space and no grounded parts or grounded parts that are insulated on the other side of the working space. Condition 2 is where there are exposed live parts on one side of the working space and grounded parts on the other side. Condition 3 is where there are exposed live parts on both sides of the working space. The higher the voltage, the greater the required depth. For example, for systems operating at 600 volts, the minimum clear distances for condition 1 is 3 feet, for condition 2 is 4 feet, and for condition 3 is 4 feet 6 inches. It's crucial to consult the specific requirements based on your installation's voltage and conditions. 110.26 The address is clear headroom. Sufficient headroom is necessary to allow personnel to stand upright and move freely within the working space. The general rule is that the headroom must be at least 6 feet 6 inches high, or the height of the equipment, whichever is greater. This ensures that workers don't have to crouch or bend over while performing their duties, reducing the risk of accidents. 110.26 C covers entrance to and egress from working space. This section emphasizes the importance of providing a clear and unobstructed path for personnel to enter and exit the working space. For equipment rated 1200 amps or more and over 6 feet wide, there must be an entrance to and egress from the working space at each end of the equipment. This is to ensure that workers can quickly and easily escape in case of an emergency. 110.26. D focuses on illumination. Adequate lighting is essential for safe operation and maintenance of electrical equipment. The code requires that the working space be adequately illuminated. The specific lighting requirements depend on the type of equipment and the tasks being performed, but the general principle is to provide enough light to allow workers to see clearly and avoid hazards. 110.26. E, as previously discussed, deals with the location of the working space. This section allows for flexibility in the placement of the working space, as long as the required width and depth are maintained. As you know, the working space may be located to the side of the equipment. This is especially useful in situations where space is limited or where there are obstructions that prevent entering the working space. 110.26. F covers dedicated equipment space. This section requires that the space above and below electrical equipment be kept clear of obstructions. This dedicated space is intended to protect the equipment from damage and to provide room for future expansion or modifications. 110.26. G addresses access and working space. This section emphasizes the importance of providing safe and convenient access to electrical equipment. The code requires that the working space be readily accessible and that there be a clear path to the equipment. This ensures that workers can quickly and easily reach the equipment when needed. Proper bonding and grounding are critical for electrical safety. Bonding refers to the practice of connecting all metal parts of an electrical system to create a low impedance path for fault current to flow back to the source. Grounding, on the other hand, is the process of connecting the electrical system to the earth. Together, bonding and grounding help to protect against electric shock and prevent fires. When a fault occurs in an electrical system, such as a short circuit, the fault current will flow through the bonding conductors back to the source. This high current will cause the circuit breaker or fuse to trip, interrupting the flow of electricity and preventing a dangerous build-up of voltage. Grounding provides an additional path for fault current to flow to earth, further reducing the risk of electric shock. The NEC provides detailed requirements for bonding and grounding in Article 250. This article covers everything from the size and type of grounding conductors to the methods for bonding metal enclosures and equipment. It is essential to follow these requirements carefully to ensure a safe and reliable electrical system. Grounding electrode systems typically involve connecting to a metal underground water pipe, the metal frame of a building, or ground rods or plates. The connection to the rebar is usually accomplished with a listed grounding clamp and a suitable grounding electrode conductor. The size of the grounding electrode conductor depends on the size of the service entrance conductors. NEC Table 250.66 provides guidance on selecting the appropriate size. Remember to always consult the latest edition of the NEC and local codes for specific requirements in your area. Electrical codes and regulations are constantly evolving to address new technologies and safety concerns. Staying up to date on these changes is essential for ensuring a safe and code-compliant electrical installation. In summary, when installing electrical panels, always prioritize safety and code compliance. Understanding and adhering to the NEC requirements for working space, bonding, and grounding is crucial for protecting yourself, your family, and your property from electrical hazards.